On this problem, we're going to look at this vector. And for part A, we're going to find the projection of u along v. And then for part B, we're going to resolve u into vectors u1 and u2 for the perpendicular part and the parallel part. So let's start with what does this look like? I'm going to draw a picture of this. Don't necessarily have to draw a picture once you have the algebra, but I'm going to just to get an idea of what we have to deal with here. So here's u and v. U is -2, -8. So I went -2 and then down 8. And v is -6, 1. So I went back 6 and up 1. So that's my u and v vector. So now the projection means, the projection of u on v means start at the tip of u and go perpendicular to v, and this distance right here, actually that vector right there, that is a very, very tiny vector. So I'm trying to think about what I'm going to do in a different color. Let's do it in brown. It's a starting at the origin and just going up to that far. So I expect some really small numbers here for that vector. So that brown one is the projection of u along v. So that's how far does u go perpendicular to v. And I can find that with this formula right here. So I need to find that, this you can see with the formula, I don't really have to draw the picture, but I like to have the picture because then I have an idea of what's going on and what to expect. So, but I can just plug into the numbers. So v, I need to get the magnitude of v. Oh, yeah, that's right, magnitude of v for the denominator. So that is square root of -6 squared plus 1 squared, which gives me square root of 37. And then for the numerator, I have u dot v. That's the dot product. So that means I take the first two terms, the horizontal components of u and v, and multiply them. I get -2 times -6, and add the second two terms multiplied together. So that's -8 and 1, and that gives me 12 minus 8, which is 4, and a dot product is a scalar. So there's my projection, my magnitude. Shouldn't have written that there. My magnitude, my dot product, and then my projection of v along u is the dot product divided by the magnitude squared times the vector. So my projection is actually that brown little, it's a vector. Might even make this picture a little bigger so we can see that. Let's see if it will let me. No. Okay. So this equals, I'm just going to do it, you know what, I'm just going to make a bigger scale of this model, a bigger sketch, so I can show I'll make you a little bit. So when this is perpendicular, I'm just kind of zooming in so we can see what that brown line is. It's the vector that is along v, and it's projected from u perpendicular, at that perpendicular. So the tip of u drawn perpendicular to v gives me this little brown vector. So to scale, it's right here. But it's so tiny that I want to make sure you understand what it is. So let's plug in these numbers. So u dot v, we got 4. For the magnitude, we got radical 37. Squared is going to give me just 37. And the vector is -6, 1. So that equals 4 over 37 times -6, 1, which let's see, pop that into my calculator. Let's do 4 divided by 37. Get that quotient as a decimal, and then multiply that to distribute times -6. And I get a -6, oh, sorry, 6.6. Okay, let's do this. -0.6. Whoops, that's not what I wanted. There we go. 6.5. And for the vertical component, that's actually just 1, so that's easy. So that was our original 0.1, the number from the top of the calculator. 4 divided by 37, so that's 0.11. So like I said, very small numbers. So this little brown vector, you can imagine it's going up to this point right here, which is such a low point. That tip, that intersection of the V and the U, or the orange line, is at point -0.65 for the X, the horizontal, and the 0.11 for Y. So that's consistent with my picture. So that makes me feel good. I feel like we did that right. Okay, and now let's moving on to part B. Part B, okay, actually I want to highlight part A, sorry. Let's do A. So here's my answer for part A. So that is that little brown vector, which is the projection of U along the direction of V. Okay. Now moving on to part B. Part B says, I'm going to erase my little sketch over here. To resolve U into vectors, U1 and U2, where U1 is perpendicular to V and U2 is, U1 is parallel to V and U2 is perpendicular to V. And we do have formula for that too, I think. Let me see here. So I'm going to use this little snippet for that information. So U1 and U2, so I'm going to edit my sketch so it's bigger so we can scribble on it. Okay, a little zoomed in now, so I have each tick mark being 2 tick marks per one, so I can see a little bit better. Still, the vertical part is still very, very small little brown vector there, ending at point negative 0.65 and 0.11. All right, so that brown part is the part that is parallel to V. So that is going to be, oops, I need brown. That is going to be the U1. And then U2 is the orange part. U2. So when I add U1 and U2 together, I get U. So U equals U1 plus U2. And U1 is parallel to V, and U2 is perpendicular to V. So I already got that U1 part. So U1 is, oops, that should be brown. So U1 is the negative 0.65 and 0.11 vector, that little brown one. And then when I add U2, I'll get U. So to get U2, and I already have U. So to get U2, kind of manipulate this because I already have U and I already have U1. So to get U2 isolated, just subtract U1 from both sides and I get U minus U1. So to get U2, I start with U and subtract U1 to get that orange line. So I'm starting with I'm going to do this in color codes. So the blue line is the U, and when I subtract off the brown, I'm left with the orange. So when I'm going to change this one to color codes too. So let's see. Brown, U1 plus U2. When I add those two vectors together, you can see graphically that I end up at the end of U. So, okay. So now plugging some numbers in here. So for the blue vector, we have given to us. That is -2, -8. And then we want to subtract the brown vector, which is that tiny one that we found, that projection, which is the -0.65, 0.11. And when I subtract the vectors, I subtract my negative components, and I get -2, my horizontal, -2 minus -0.65, so it's really plus 0.65. That gives me 1.35 is my horizontal. And my vertical, subtract the verticals, so that's -8 minus 0.11, so that's a -8.11. And that is that orange U2 vector. So that is my answer for part B.